Hello there! In this video I would like to announce a new tool I've been working on. It's called Telplin. Telplin allows you to generate signature files from Nojaf. Before we dive into the tool itself, I'd like to highlight why would you use signature files in the first place. There are three key benefits to using signature files. One is during compilation, another one is how they affect reference assemblies, and lastly, your editor could gain some performance. A lot of things I'm going to talk about are available in .NET 7, so not everything might just be available yet. Parallel type checking is a very recent addition to the F# compiler. It was merged a couple of weeks ago at the time of recording. It allows type checking of files that are backed by a signature file to happen in parallel. Reference assemblies for F# are going to be included in .NET 7. Reference assemblies have a thing called the mvit. The mvit is sort of a fingerprint of your reference assembly, and when your public API changes, your mvit changes. And when you use F#, your mvit might change even though you only changed some private parts of your assembly. Having signature files in place really helps stabilizing the mvit, so that's another benefit there. Parallel checking with signature files on and reference assemblies are not in the official stable .NET is the case yet, so I won't be covering those in this video. I might make a separate video for that later on. For the background compiler, I will explain this in a short demo. Let's open the Phantomus project in here. If we take a look at Phantomus core, it has a bunch of signature files. Now what's important here is when we have signature files, we can tweak our editor. Let's just take a brief look at the settings. So inside of my writer, there's a F# compiler service setting, and most likely this is available in other editors as well. But here you can check on this skip implementation file analysis when possible. And when you turn this on, it will, when it opens a file, so if we are to open q.fs for example, it needs to type check all the other files that came before it in order to analyze q correctly. So if we're doing, you can see the analyzing over here. This is happening, and it really needs to check all the files. But because that setting is on and we have some signature files, it is able to skip the type checking of the files that have a signature file. This is quite significant because if you take a look at AST transformer here, the file itself is rather large. It has 1700 lines. But looking at what it actually exposes, the file, the signature, it only has two functions. So for the compiler, it's an enormous improvement if it only needs to check, type check within the signature file, and if it can skip this large file completely. So that's one benefit of having signature files. Your editor will be a lot more snappier. Before the main event, a short overview of what Telplin is. I created a sample application over here using .NET 7 SDK, and if you take a look at it, it has a file which has some F# code, and if you want to start using signature files for this, there's a way to do this right now today in the F# compiler. What you can do is you can change your fsproj and put something in there which is a other flag in a property, and you pass in --all6. If we now were to build our project over here, it will have created a signature file for all my F# files. In this case I only have one, and it has created a signature file. But let's add this to our, so let's just remove it for now because you typically only want to generate once and not every time you run this. Let's add our signature file into our project and then compare both of them side by side. So first off, you can see we already have a couple of warnings, and why is that? So if we look at our signature file over here, the struct that we had over here, so it was defined as struct end, is a bit different than what the signature generated. So the signature uses the other syntax for that, but because of a recursive nature of these types, the keyword was printed wrongly, so that's already one problem. And if we scroll over here, we can sort of see, oh, there was a nested module with some attributes. The attributes are gone. The class end is also having an additional type, even though the signature doesn't really need this. So let's just correct all these things by hand. And there we go. Another thing worth noting is that I had a literal in the beginning, and I'm using this literal later on in an attribute. And what you can see here is that the value of this literal is just being printed, well, as is, and it's not really using the defined literal over here. So that's all a bit of an unfortunate thing. So the generation isn't perfect. And one of the reasons for that is that this generation was done purely using the type tree information and doesn't really know anything about how the source code was written. So it has no notion of the untyped syntax tree. And this is where Telplin comes in. So you would typically install Telplin, .NET tool install. You would typically install Telplin as a global tool. Because the way it's designed is that Telplin is something you're going to invoke once. Once you have your signature files, they're going to, have their own life cycle, and you'll make changes to your implementation, to your signature. You'll trim as much as possible from the generated signature file, and you typically just want to get started, and that's really where Telplin comes in. So what we can do now is we can call Telplin-help. Note that Telplin is in a very early stage, so what's being illustrated right here might change quite rapidly. The point is that you can always use the Telplin help, and then you can sort of see what its arguments it takes, and it takes a binary log file. Now the way this works is that we first need to create a binary log using MS-build, and we need to do a rebuild of our project. Why is that? Well, just so that all our F# compiler options are actually captured in that bin log file. And in the binary log, we can just Telplin can read those and then use it to construct everything it needs to get the same type check information which the compiler had during the build. So this is a bit of just a step to get to the right information inside of the tool. So what I can do now is call Telplin, pass in my MS-build log file, my binary log, and then it will process everything it finds in the project. So it found all the files and it generated everything. When you don't specify anything, it will just do like a dry run, so don't print anything to disk. And when I add write over here, it will write all the files to disk. And what we can see now is that a lot of things are slightly different. Notice that my open statements were just copied one by one. If I take a step back and take a look at what all 6 did, all 6 did not open anything. It just references everything by the fully qualified name, but that's typically not how you would write how you would write your own code. So the difference there is that Telplin just looked at the input code and just copied everything that's available. It took the literal as is and then found the attribute, and it just took the attribute as is as well. So that's already one thing. For the structs, notice there's no attribute this time because, well, the definition also here did not have that attribute. It just created a struct and created all the values and took the constructor over here. So if there is information in the syntax tree, Telplin will favor that before really resorting to the type check information. And that's why a lot of things are rather very on point when it comes to how this was generated. So basically the untyped tree was walked. So the untyped tree is everything in what you wrote in the source code. And then Telplin is just being used. It uses Phantomus to construct a new signature file, and as much as information as possible is just maintained from your original source code. Telplin, of course, is not without bugs. You can use an online tool to report them, and when you use this tool and click the Get Signature file, it will have taken your source code and type check that, generate a signature file, and then type check the result of the implementation with the created signature file to really see if it's valid or not. If we take another example, Telplin isn't fully completed yet, so there are still times where the information is incomplete or the tool just doesn't work. And when you click on Get Signature over here, you'll see there's an error message. The generic type T should have a constraint that it should be comparable. So Telplin did not generate that in the signature. What you can do in those situations is the Report Issues button, and this generates a issue in GitHub, a template of what you had, what the signature was, and then you can sort of explain what went wrong, what the signature should be, and you can insert a meaningful title. And that's really the best way to report issues. There's also some limited documentation if you're interested in, covering again the motivation of why this tool exists, how you can use it, or basically the installation, a bit of a technical overview of how it actually works, some contribution guidelines if you're interested, and then again a link to the online tool. Lastly, I want to highlight some community projects that are used in the Telplin repository. I've used Binwin has fun build for my build scripts. It's an interesting alternative to Fake. You can basically write an F# script, reference the NuGet package, and then open the fun.build namespace. And from there on, you can create pipelines. Pipelines contain of stages, and every stage is able to run something, and the run just returns an exit code. So in this case, I'm just running something manually and then returning 0 if I assume everything was okay. But it can also just run little commands one by one. And that typically simplifies a lot of things you want to do in the CI/CD scenario. Just like running certain tools, it's a lot of orchestration around the .NET SDK, and these are all very interesting things to do, and I really much enjoyed how interesting the script is. So you can just run this like you would run any other build script, .NET FSI, and then just pass in the build. And that will just kick in and see all your stages of your pipeline and just do all the work. Or you can run the build script with a -p to run a specific pipeline. So for my pipeline, I'm going to run the watch targets, and that launches everything we need for the online tool and the documentation. For the online tool, I used Perla by Angel Munoz. Perla is a front-end developer server written in .NET, and that allows us to write a Fable and React application without installing Node.js. We don't have a package JSON file, and all our dependencies are coming from a CDN instead. So you can see we have a configuration file for Perla. How should the dev server read behave? How should the build behave? And then I have this list of packages where I just say, hey, if I'm using React in my JavaScript code, it actually means get React from this. So this will then generate an import map, which is something relatively new for browsers. But you can just write code like you have, like you're used to. So this is just a Fable with React combination with a little bit of Elmish code inside here as well. So none of that really changed, but I was able to just spin up a developer server similar to how you would use Webpack or Vite, and it's just it's a installed .NET tool. So you can see here I've used Perla, and then from there on it's just .NET Perla and do your stuff. So it's really interesting to sort of see how tools like this can just be generated with .NET only tooling. And that's all for this video. See you in the next one.